Hey everyone, my name is Xavier Harding, and I'm on the content and marketing team here at Mozilla Foundation. And today we're talking about using AI to track air quality. So this month is Earth Month, and in honor of that, you've probably been seeing us talking more and more about the carbon footprint of the things that you do online. A lot of stuff ends up in emissions. So today I'll be chatting with two Mozilla Technology Fund awardees about how they're using tech to track carbon emissions in their home country and across the globe. Here with me today is Fernanda Carlés of AI-driven air quality forecasting for Asunción, Paraguay, and Satish Kumar, creator of Methane Mapper, made by the group iClimate. How are you both doing today?
Thank you so much, Xavier. I'm doing pretty good.
Yeah, how are you doing, Fernanda?
Hey, Xavier. Very well, thank you.
Good, good,
Excited
good.
about
Okay.
the interview.
I'm excited too. I'm excited that our foundation, Mozilla Foundation, is talking more and more about these topics. So I'm really glad you both could join me today. Okay, so Fernanda, maybe you can start. What is your project and why track air quality in Paraguay?
I come from academia. I'm a mechatronic engineer, and I've been working with the National University of Asunción to use AI to study and forecast air quality for my city. So this project is based on trying to make all this research that we're doing into tools for the public. So what we're trying to do is create an open source website and a bot alert system to give information to the people of Paraguay about how the air quality is going in Asunción and how it's going to be in the future. So give them forecasts and give them tools to take better care of their health. So that is like the whole scope of my project.
That's really cool. That's really cool. Okay, so Satish, how about your project? Do you want to tell us about that?
Oh yeah, just like a brief intro. So I'm a final year PhD student at UC Santa Barbara, and I've been working on methane detection for last 5 years as of now. And the work methane mapper is an outcome of like series of work that we have been working. And the methane mapper is an AI technology where it is dedicated to do methane monitoring from any kind of sources from aerial imagery. And the aerial imagery could be your airplane based, satellite based, or drone based. And when you say any kind of sources, that could be like a point source emissions, where the emission is from a specific point, or like an emission from a diffuse source where it is like a landfill site, or let's say like agriculture farms, like those. So it's like a monitoring solution for those.
Cool. What made you want to pursue that?
So like I come from like a agriculture background. Like I was a full-time farmer before I started like my PhD over here. And that's why like I have like an initial motivation to do something towards environment. And when I started my work there was the first project was proposed by the Aerospace Corporation at like our lab. They were interested in tracking something else, but because of the proprietary reasons, we were giving, okay, why don't you go and look into the methane emissions? That might be a similar problem. I was like, yeah, sure. And then I started exploring the problem. I found it more and more interesting and more relevant to the environment. So that's how like then that was the start, and then I never left it from there.
That's cool. How about you, Fernanda? And also, not only what made you want to do this, but how hard is it to track emissions in a place like Paraguay?
Well, the idea behind this was to, as I mentioned, we're doing all this research from the university, and we wanted to, but it's all like hitting inside papers and reports. But we really wanted to start engaging with the public more. So we're building all these tools that really can help give people information about how to take care of their health and about how the air quality is actually in Asunción, because it's kind of like air pollution is kind of an invisible problem, let's say. So we wanted to do that. We didn't really have a lot of experience on that, but we started engaging with the open source community. There are open source projects here that are working on air quality monitoring. So that's kind of like the whole idea of the project and why we wanted to do it. And tracking air quality in a place like Paraguay is pretty challenging, just because we don't really have, let's say, state funded systems to do this. So in Paraguay, we have three main projects that work on this. One is a private project that sells their data. The second one is our project that we've been working since 2009 we have sensors on the ground that measure air quality in 10 points across the city. And the third one is this open source project that uses very low cost sensors to do, let's say, citizen monitoring of air quality in Paraguay. So it's challenging in a lot of ways, just because we don't really have like a state program to ensure air quality monitoring. We're always working on what is the best way to do this, what is the cheapest way to do this. So it's a lot of a grinding, let's say, in a way. But it's a very interesting work, because when you don't have a lot of resources, you have to be very ingenious. So in like conclusion, we're kind of like trying to merge efforts, with the open source community and academia, and just try to make the community stronger through collaboration,
Yeah. I love both these projects because it's interesting seeing how, Fernanda, yours is more on the local national level, not local, but the national level, and the Satish, yours is more on the international level, if I have that right. You mentioned sensors, and I kind of want to, we have a very techie audience here at Mozilla, so maybe we can geek out and talk a little bit about those sensors. Actually, I do want to talk about not just the hardware, but the software, but we'll start with the hardware. So when you say sensors, like what are those sensors, and what may be the drawbacks, the pros and cons of the sensors that you use to track air quality in Asunción?
So as I mentioned, because we like all the projects that we do, we have to think really hard around what kind of hardware we're going to get, just because we don't know if we're going to be able to replace it. And the resources sometimes don't allow us to buy like professional air quality monitoring sensors. Maybe cost around $25,000, $50,000,
Wow.
some of them. But we're using a sensor called OPCN2. So this is considered a low-cost sensor. It's around $500, so a lot cheaper than, let's say, more professional sensors. But this sensor is really interesting because it has been evaluated against very like high-end sensors, and it yields really good results. And specifically, but it does have like some cons, let's say. So these types of sensors use laser readings. So we have like unfortunately I couldn't bring one today to show you guys, but basically it has like it's a sensor that has a reading chamber that uses a laser and Mie theory of light dispersion to count particles that go into the reading chamber. So it's pretty accurate into counting particles, but not differentiating what particles are due to pollution and what particles are due to, for example, humidity. This is like the biggest problem with this type of sensor. So to actually get it going and have precise readings, we do have to do a lot of corrections that come from humidity. And well, Paraguay is a very, very humid country. So there's a lot of work around sensor calibration and just taking into account humidity to get good readings. So the system works very well, but you do have to take into account these types of things. So a lot of thinking has to go around how to use it properly,
I wish your project would lead with like, we're using lasers to save the environment. If you led with that, everybody would be on board. Okay, so Satish, let's talk about the tech that you use to track methane across the globe. I know there's hardware and software. Maybe we could focus on the hardware for now. What are you using?
Oh, so in this one, the hardware is a little unique. So it is called as like a hyperspectral sensor that sits on either on an airplane or a satellite imagery, like satellite. And by hyperspectral, I mean is like whatever you see on your computer screen, those are like RGB, like 3 channels. So you see in the visible spectrum, 3 colors. So just imagine you are taking an image right from visible, that is like 400 nanometer, all the way up to like shortwave infrared, that is 2500 nanometer. And you take an image at every 5 nanometer step size. So instead of 3 channel image, your regular imagery that you see, you'll end up getting a stack of image that is 432 channels. So that is what a hyperspectral imagery is. And why it is designed like as Fernanda mentioned. So here we are specifically detecting like one super pollutant, which is methane. So the gas have a certain like vibrating frequency. So like the gas molecule like rotates at a certain frequency. So and that wavelength is actually around 2200 nanometer, like especially like 20 from 2000 nanometer to 2400 nanometer. So you go and look into that specific range, you'll pinpoint, okay, this is where methane is. So this is the like hardware sensor that is needed for like capturing such data so that we can pinpoint like specifically methane and differentiate it across others. And it can be put on an airplane, and then the resolution varies because the airplane flies at a height of 3 kilometers above the ground. You can put it on a drone, which flies like maybe a couple hundred feet above the ground. So you can record data from there, like at a much higher resolution. So you can detect emission as low as like 1 kg per hour, 2 kg per hour. And then you can put it on like current. There are few public satellites and commercial satellites too. To name few, these are Sentinel or Maxar. Those are in the orbit 700 kilometers above the ground. So there it have low spatial resolution. So they have certain detection threshold, like you can only detect as low as like maybe like a 30 or 40 kg per hour of emission from Maxar up to like a minimum of 800 or 1000 kg per hour of emission from Sentinel. So this is the type of sensor which is needed for this.
I see. I feel like when you talk about this, it sounds like we're definitely like living in the future. If you're talking about drones and sentinels and using that for science, like this feels like some futuristic stuff. This is a hard question for you both. So we've been talking a lot at the foundation about AI. We've been talking a lot about the carbon footprint of AI and the amount of energy it takes to not only use AI, but to train AI. I want to talk to you both about your use of AI in your projects or your use of software in your projects, and how do you square the circle of the AI maybe not the greatest for the environment, but we want to use it to track the environment. Is that something you both are thinking about? Maybe we start with you, Fernanda.
Yeah, so definitely we've been thinking about our carbon footprint and energy consumption, but I think that from a different side. So for like the way that we're using AI for our project is specifically for forecasting. So what we're trying to do is predict how the air quality is going to be like 6 hours from now, 12 hours from now, and try to give this to the public. And the idea is that there are many, specifically like in the past few years, deep learning has been like the primary technology that has been used to do this. But deep learning usually uses a lot of resources, a lot of computational resources. And this is kind of like the worry, that like the preoccupation from like the environmental side. But in our case, we were thinking more about like our time, our processing time. So as I mentioned, we in the university we have a supercomputer, like a cluster that does these experiments very well, but we have a lot of projects. A lot of people are always fighting to use this. So we were thinking, okay, what kind of technology we can use that for example, sometimes I can run experiments on my computer. I can train models on just my computer. So we started looking into that, and we found that there are a lot of ways to use like simpler technologies, like simpler AI technologies to do this kind of work. Specifically, we're preferring using machine learning versus deep learning. And from our perspective, it was more of a question like, how can we do experiments that Fernanda can run? Like put like 8 p.m. she starts running them, and 8 a.m. the next day they're done, so she can continue working and not spend 2 weeks like frying her computer. But that was kind of like our question. But as a result, like a secondary result, let's say our models are pretty light. They use very low processing time, and as a result, very low energy. So yeah, we definitely take that into account. Like our whole research is pretty much based solely on machine learning. And this is like it's very good in terms of processing, but it also like the con of using this is that we do have to do a lot of data analytics and a lot of feature engineering to get these simpler models to actually work, like to use them in a very smart way. So there's a lot of work done in data analysis and just trying out different combinations of features, also trying out different look-back windows for each type of feature. And this comes from a lot of data analytics work. So, for example, I have to do a lot of testing into like in the look back window, should I give it like 2 days of data, 1 day of data, maybe just some specific points that are really very, very well correlated, so that the models are very light and very optimized. So yeah, that's kind of like how we're handling things, and we really do. There is actually a lot of work around and a lot of like philosophical talk around why are we using like deep learning and these like heavy technologies instead of just trying to use like lighter models and simpler models. And the answer is that deep learning usually is easier to handle in terms of like feature engineering and stuff like that. So you just give it a lot of data and the model kind of understands it and learns how to use that data. But we're kind of trying to do that ourselves, like, and use the models like in a more optimized way, let's say.
Yeah. Satish, is that something you're also thinking about?
Oh, so in our case, and when it comes to methane, like as I mentioned, it's like a super pollutant we are dealing with. So robustness and scalability, because we are mapping the whole planet kind of. So those are the most important things. And when you are mapping at such a large scale, so things changes way too frequently on the ground. There are thousands of other things on the ground which mimics methane presence. So we designed a deep tech from scratch. It is like a AI based technology, and it uses transformers in the backend, and transformers are infamous for being data hungry and like using a lot of compute. So what we did is we optimized the training time of transformers too. So that's where the research part came in. So the design of transformer networks is in such a way that they are specifically designed on like there's a key value and query pairs, like a triplet of these three. And usually when you start training them from scratch, these are initialized randomly. These are random vectors completely. And then if you push the network to come to a conclusion or to a conversion so that these three are few useful information, it takes insane amount of information. So what we found the trick in between is, if we use the query as pre-informed information, if we provide some information about methane already to the queries, we can converge the network pretty quickly. So we can reduce the whole training time by a lot of amount. So that's where we use some deterministic model in the backend to generate some potential locations where the methane could be found. And those has been there sitting there in the information theory for like last couple of decades. But they are heavily prone to false positives. They produce like 60 to 70% false positive. So we provide those to our in the form of queries, like, okay, go and just look at only these locations and then let us know what do you find, which one is a true positive and which one is a false positive. And we were we were able to cut down the training of time of the transformer which needs 10,000 images to train, to as low as like 2,000 images. So it's almost like 1/5 of the scale.
Wow.
So and that made our model complete, like super robust too. We tested on varying type of like terrain. We tested in like dry regions, semi-arid region of California, and then even like dense vegetation, and it works pretty well.
Yeah, that's awesome. Yeah, I wonder, do you both feel like this is something that a lot of scientists or air quality trackers are talking about, how the ability to use smaller AI models that might be better for the environment in order to still do the same work? Is that something a lot of scientists or people in your field are talking about?
Yes, in that case, end of the day, is the only the training which is more expensive. But once you are done training it, then the inference is never expensive. Inference is super cheap in that case.
When you say inference, you mean like running a search query, basically?
Yes, exactly. Yeah. So when you have a trained model and you go and test it anywhere, because when you actually put it as a product out, that is super slow, like low in compute.
I see. I see. Okay, so maybe we can broaden out from the techie nerdy stuff and we can get to like real world aspects of this. So Fernanda, this is you actually live in Paraguay. You're working to track the air quality. Has there been like real world benefit? Have you been seeing real world benefits of your project?
I think definitely so. Like with the forecasting, let's say just going a little bit back into the technology, we are the research that we're doing from the National University has been like the first type of research done into forecasting for the region. So like my specific region, like Paraguay, North Argentina, Bolivia. So it has been like very interesting in that sense. It brought up a lot of conversation around our area not having enough stations to monitor, and not like this is a problem that is not being paid attention to. So we do have a lot of great results in terms of our like monitoring and understanding air pollution here in Paraguay. So for example, in I think last year we came up with a paper around how air quality was really bad in Paraguay during COVID season, and this was very weird. Almost nowhere in the world this happened. But it happened in Paraguay because we have very specific problems that are very different from how air pollution works in other places. So in the global north, air pollution is usually linked to like energy production and industry. So in a way, it's very, it's in a way easier to understand because you know that industries work from this time to this time in these days. So you kind of can use this information to predict air quality. But in Paraguay, like high peaks of air pollution usually come from wildfires and stubble burnings. So we do have a really big problem around this. In Paraguay, we are seeing like very big effects of climate change. For example, we have very extreme heat waves that are kind of new to us. Like 5 years ago, like the temperature, it was always hot here, but not as hot as it is today. And it's also, we're also going into a period of La Niña, so like a lot of dryness in the environment. So we do have a lot of wildfires that are not really being monitored and reported by government agencies, but are very noticeable from the people notice this, and we do notice it from our sensor readings. So we do have a big problem around this specifically, but we also have a big problem around like the wildfires are like things that happen kind of spontaneously, and they're very hard to predict, like the kind of impossible to predict in a way. But we do have like a very high, in Asunción specifically, we have a very high baseline level of contamination, of pollution that comes from fossil fuel burnings, and specifically from vehicles. So what happens here is that we have a lot of, we don't have really good public transportation. So we have a lot of cars in our roads, and most of these cars are pretty old and they use diesel. And so diesel is like pretty much the worst type of fuel for cars. It's the type of fuel that gives a lot more emissions and more pollution to the environment. But also we do have like a very big industry going around fossil fuels in general, like selling fossil fuels. So Paraguay is the country that has the most gas stations per capita in Latin America. So we have around one gas station per like 3,000 people, and like the average in Latin America is one gas station per like 11,000 people. So we have like almost 4 times as more gas stations than the average in Latin America. So yeah, like those are the main sources of pollution, I think. And this is why I think that our research and our work is very interesting, because this is very different, like very specific to our region, like Global South. And all the research that has been going around forecasting this air pollution usually comes from the Global North, where it's a lot more predictable and a lot more manageable. But this kind of research is very interesting. It just gives to give like Global South people more tools into predicting and understanding the problem.
Yeah, that makes a lot of sense. I guess in like developed countries, you can predict emissions around people going to their 9 to 5 jobs and then coming home and using a lot of electricity in their homes, versus a wildfire is way more sporadic and more just spontaneous, like you mentioned. And the diesel thing is such a good point. I didn't even think that, like, yeah, older cars may use worse kinds of fuel sources and just worse for the environment. So on that kind of diesel train, or whatever the metaphor is, Satish, we can maybe pivot to or segue to methane emissions. What are the most common methane emissions across the globe?
Oh, First, I want to check. Can you hear me
I can hear
clearly?
you. Yeah.
Okay, perfect.
Perfect.
So the most common sources like of methane are basically like one is oil and gas because methane is a byproduct of petroleum. And in most of the cases, it is just released in the atmosphere. The reason for that is one is the missing infrastructure. So like most of the oil gas, they like less infrastructure to capture this gas and then use it. So they end up releasing, and these are in tons, like hundreds of tons that's released. Second major emitter, so this constitute almost like 33% of the total methane emissions.
Hmm.
And almost next 30% comes from agriculture industry, where like these are like emissions from cows and like cow or dairy farms. Each cow produce approximately like 200 to 250 liters of methane per day. So just imagine like one
Wow.
single dairy farm have approximately 10,000 cows.
That's a
So,
lot.
and there are a bunch of those like spread across the country. So those are like, surprisingly, cows are one of the biggest emitters too. And then other sources are, for example, mismanagement of waste in landfill sites, like separating the dry waste and the wet waste, like not in a correct way. For example, I was looking at the statistics of US only. In US, there are like approximately like 400 landfill sites. Half of them are owned by government and half of them are owned by private sectors. But 87% of the trash goes to private sector.
Wow.
So that
Wow.
means like, if like that means 50% of the landfill sites are holding that 87% trash. So definitely there's a lot of mismanagement of trash, like it's not being separated like dry and wet. So there's a lot of like degradation of biodegradable material in that, and that leads to methane emissions. So these are the major sources which causes this problem. And
So
like just one like and this one single gas is responsible for like 30% of the global warming. And just from
wow.
these three main sources. So that's why like every year in climate summit, this is like they are focusing more and more on methane, like COP26, COP27, and 28. That if you can just address this one problem where we know where it is coming from and find those out and then plug those back, 30 like it's a low hanging fruit. 30% of the problem is already solved. So that's why it's so critical and to actually address right now.
So I'm hearing you say is 30% of the kind of methane emission problem across the globe is fossil fuels, trash, and cow emissions,
Agree.
cow farts.
Mhm. Exactly.
Yeah. And I know, Fernanda, you were telling me actually there's like an interesting because cow farts are a problem in Paraguay as well.
Yeah, definitely. As I mentioned before, like one of the main sources of extreme air pollution in Paraguay is wildfires and also stubble burning. So this is where people who work in farming industry burn grassland to renew the soil in a way. This is a practice like it's very extended in Paraguay, completely extended, like, and it's not recommended in any way.
It like does it
Um,
make the soil better?
Not really, actually. It's just
Okay.
it's kind of like a fast way to clean it, let's say, and
Okay.
it does kind of like help with plague control. But this is pretty much everything. Like that, this is all the good that it brings. Like in the con area, it does like spike up air pollution, but also like it kind of denatures the soil. Like it burns like all the good things that are in the soil that make for example
Like
that
nutrients and stuff?
that make, yeah, the nutrients, you know. And this is done because Paraguay is like our main industry is farming and cattle, so we do have a lot of cows and a lot of cattle around in the whole country. And so they burn the ground so they can grow new grass for feeding cows. So yeah, in a way we have a lot of cows, and we're also like burning a lot of soil to maintain these cows. So yeah, it is a really big problem. We really don't deal with methane specifically. We deal with CO2 emissions, so the pollution that comes specifically from burning. But as I mentioned, this is a really big problem. This is one of the main sources of pollution in the country.
Wow. I want to go zoom back into like the tech of all this. Maybe you both can talk about how the internet specifically has changed the conversation around tracking air quality. Maybe we start with Satish.
Oh, so in this one, internet has really helped. One is if internet wasn't there, this project wasn't possible because specifically on methane detection, like there are so many tiny groups which are working like independently. And when I started working on this problem, like after the first phase, I realized the reason that the computer vision or like AI community is not working on it because there was no ground truth data or ground truth information to train such algorithms or build such robust models. So because of that, only like internet or like only I was able to reach out to find out all those groups, reach out to them. Like there was like to mention few, I reach out to a bunch of NGOs. There's like Carbon Mapper, then Meta Group at Stanford, which is like Methane Emission Technology Alliance, then the Atmospheric Chemistry Modeling Group at Harvard, then like company in like Poland also, which is University of Polytechnic Valencia, and then Orbio Group in Germany. So because of that, I was able to like talk to them, kind of bring them all together to genuine, hey, like, I mean, you all have specific expertise and we need something like that. If we can bring certain collaboration to like solve this problem together. And that's how like another product of methane mapper is like the methane hotspot, like the data set that we built so that the community can progress more further. And it's the largest publicly available data set that we have made available for everyone to use. And I think
Wow.
within
Wait, so
6 months,
you're saying it's the just to like emphasize that it's the
Mhm.
largest available public data set
Yes,
of methane emissions
yes,
globally.
yes.
That's amazing.
Like where people with ground truths, where people can actually like train their machine learning methods. And within 6 months, we have almost 165 plus downloads on the data.
Oh,
And I'm like day in and day out, I'm like people reach out either by email or GitHub uh, to like, I mean, if they're facing any issues while downloading it or accessing it or visualizing a particular form. And these are like companies also, like industry, academia, government also, because when they download, I kind of created a Google form to track who all are using it and what are they going to use it for. So for all different sectors, like I see people like I mean, like are using it and to work for develop further on top of it. So
that's
that like,
amazing.
and I think because of internet only, it started this kind of like it's a tiny revolution, I would say, but it started somewhere and now people can take it further too.
That's pretty fantastic. Okay, so Fernanda, how about you? How's the internet changed the conversation around tracking air quality in Paraguay?
Well, I think I want to start with kind of like a personal story and how I got to actually start doing this research. So back in I think maybe 2021, I was looking into like new data science projects and stuff like that. And I noticed this project, this open source project here in Paraguay called Aire Libre. So this is a project that, as I mentioned before, they use very, very low cost sensors. So like $30 sensors to kind of do citizen monitoring on air quality. And I noticed this online, and I remember when I saw it, I thought, wow, I didn't even know this was a problem. You know, like air quality for most of us is, and air pollution is kind of an invisible problem. Maybe you notice that the air is kind of off, but you don't think about it much. So I started looking into this project specifically, and then I talked to it about it to some people in the university, and they told me, hey, we have like an air quality project here. And I was like, I didn't know this existed, you know. So I started like talking to them, and then I got into the research group. So for me specifically, like this project, like this open source project, really sparked something in me that has become like my work today. Like I've been working on this for 3 years now. And so like, and the whole basis of my project, like the whole idea for me was like, I didn't even know that this research and this technology was being built in my university. And I thought about that, and I thought about how I got into the research, and I thought, this is we really need, as the university really needs to put this out there, because it really does spark public conversations, you know. Like when the Aire Libre project started, people really started talking about this issue, like why is the air like this, why is it showing like the air is like unhealthy, like I don't feel it, but it definitely does something to my health. And yeah, so for us the idea of this project is to keep the conversation going, like showing our research, showing we have these tools, we can show you how the air quality is going, we can tell you about how this is impacting your health. And we want you guys, and we want people to start talking about this. And this also already happened with the Aire Libre project. So we really want to just kind of continue this conversation, because these are the conversations that really spark changes in places like Paraguay. You know, we are like global South country, we culturally we don't really talk about like problems with the government a lot. We don't really have a lot of social movements around political issues. This is something that happens specifically in our country and a lot of countries in Latin America. But the internet, social media has really sparked a lot of conversations around all sorts of issues. And we really want to use we really think about the internet as a public space for debate. And we definitely see how it has changed how people view issues in how people learn about issues. And so yeah, the internet for us is like is our medium to talk about our research and to get people start to worry about this kind of thing and to start like denouncing when they see fires, talking about it and asking people in like places of power to start doing something about this, you know?
Yeah, it's really great to hear that Aire is doing stuff to like, it's great to hear that they inspired you to do this work and now you're doing this work. And like, I bet they would love to hear that. And it's also just a little ironic that like, it's an invisible problem, air quality, but also the solutions are sometimes invisible to people who might care about these issues. Like you didn't know that that was happening in your own university. I wonder if we can, maybe I'll ask both of you and we'll start with Fernanda. Who are some other folks doing this work that you want to shout out or that you want people to pay attention to? Are there any other folks doing this work? Maybe in Paraguay,
Yeah.
and then we'll go to global for Satish.
Yeah, well, in Paraguay, as I mentioned, like the only project that's really working on this is the Aire Libre project. They have inspired me a lot. And actually, as part of this project, we are working with them. So they have data from 2020 around air pollution. And they do have like these low-cost sensors that are, let's say, unsuitable for scientific research, but they still give very useful information, you know? So like, I know people that have, for example, have asthma, and I talk to them about this project, and now they're using it every day to just kind of see if they need to close their windows for today or see if it's a good day to go out for a run. So yeah, for me, the Aire Libre project has been a real inspiration, and actually, as part of my project, we are collaborating with them. So just trying to find out if how we can. We are trying to build new models around their data. So maybe to try to donate some forecasting models for them specifically, see if they can use it or not to improve their project. But also in terms of communication, we are kind of trying to work with them because they do have not an extremely large platform, but they do have a good platform. Like they do have already connected with people who are interested around this kind of work. So yeah, like the Aire Libre project for me is like, I love you guys. Thank you for the inspo and very happy to be working with you.
It's great when like your heroes get to be your coworkers. Like
Yeah.
I have done that in the past with being like a former journalist where like suddenly I'm working with the people I like admired from afar and it's always cool. Okay, so Satish, who are some other folks that you'd want to shout out that are doing work similar to yours in this space when it comes to tracking global emissions?
So in this one, I want to this was the whole shape of methane mapper was like there was a big help from geography department at UCSB, Professor Dar Roberts. He is like a legend in this field. He has been working for decades on methane emission detection. So he was the one. Then I got inspired from like the Meta group at Stanford, where like Dr. Evan, he helped a lot in evaluating the quality of our method, like how well we are doing it, and then structuring the test around like so that before we share it to someone, like how well it is in. And then Dr. Daniel Veron and Elise from Harvard Chemistry Modeling Group, they helped a lot in building it further, all the queries that we're going through back and forth. And they are also like superstar in the field. Then Robert from group Orbio Group in Germany, he runs a company, and he helped a lot in structuring this project, providing data, then providing assistance, then expertise in the group specific to the problem. And and then especially Carbon Mapper, which is like they gave a huge help in developing the data set too. So
That's
these
awesome.
are the
That's really cool. I think we'll start to wrap up soon. But we didn't take questions during this panel, but you should feel free to send in your questions to Satish, to Fernanda, to Mozilla on Twitter, LinkedIn, all the places you can comment on our social media we're on TikTok as well. So maybe to end off, I want to ask you both, is there a way that folks can track this themselves? Where would you point folks to if you want them to keep up with information about these topics? Maybe we can start with Satish and go to Fernanda.
So yeah, thanks. In this case, you can follow us on LinkedIn. Just follow the group High Climate. So we are like constantly updating that. We made that recently, but we'll keep on updating that with more information about methane. And our whole source of methane, like the code base, the AI model, and the data set, everything is completely public. Just Google methane mapper without space, and you'll find it. And if there's any other queries like how you want to use it, so you can just send me an email directly to at you can find the contact via like reach out to via LinkedIn, or if there is any other like by university email to Satish Kumar, my first name and last name at UCSB. And through the help of Mozilla, we are working on making this completely public, where like we are providing the resources too. So majority of the grant we are using to set up hardware resources, so that because thing is these are like compute intensive model, so they need like some state of the art infrastructure. So we are providing that for public use and deploying the models over there. So we are designing the pipeline in such a way that let's say you are sitting at a particular location and you want to see around you in like a 10-kilometer radius, like how the air quality or how much methane is around. So you can provide your address and the time you want to monitor today or a month from now or in a year from now. So you can just provide the timeline. Then our pipeline will query the nearest satellite that was available at that time and at that location, will download the data, run the analysis, and then notify you when, hey, around you in your 10-kilometer cross 10-kilometer radius, this is how much, these are the spots where methane emissions are happening actively or in last 1 year, and how much those are, like the quantity, like there's like 10 ton, 5 ton, and at what rate also, like emission is at like 100 kg per hour, 10 kg per hour, something like that. So
That's really cool. I love that you're like surfacing that information in like a notification on your phone kind of way. Okay, so for Fernanda, how about you? How can folks follow the work that you do and stay on top of updates here? And where would you recommend folks follow you and your work?
So right now, as part of this project, we are actually working on like our public face for the project. So this is something that's going to come up in the next few months. We're going to have a public website where you can see our forecast and lag data, also statistical data, and ask for open source data to analyze the data yourself and see how the air quality is in Paraguay in general. We're also working on Telegram and X bot alerts. So the idea is that in the future, you'll be able to subscribe and get notifications on how the air quality is going and how you can expect it to be in the near future. You can contact me in my LinkedIn profile at Fernanda Carlés is my name. So I can, if you want to talk about this or have any questions, please write to me there. And yeah, and also just to mention, like the Aire Libre project is a project that is going on right now that you can actually see their measurements. As I mentioned, they use low cost sensor, but they do give interesting information about the environment either way. So you can visit their website at airelib.re. So aire, lib.re. And you can check it out. Also, something I wanted to mention about this project that I didn't mention before is that because you do use low-cost sensors, anybody can build an air quality like sensor kit. It costs around maybe $60 to build the whole thing, and you can put it in your house and connect it to the project. So this is very interesting because they have like we only have monitoring stations in Asunción, but they have monitoring stations in like the countryside in very small cities that could possibly like in the near future are not getting like super good sensors, but they can monitor thanks to the Aire Libre project and these very low cost sensors. So yeah,
That's awesome.
so visit it if you want to build your own sensor. They have instructions and you can just talk to them and connect it. And it's now they have like sensors in a lot of sensors in Paraguay, a lot of in Asunción, some in some cities, but they also have sensors like in Argentina, one in Costa Rica. I saw like last week. So this is open invitation for anyone that wants to start doing citizen monitoring, you know.
That's awesome, though. Yeah, we love an open source, open call to DIY your own, build anything. We can have links in the LinkedIn comments for all the stuff that I just mentioned. But I just want to thank you so much for your time today, Fernanda and Satish. It was so great talking with you. And thank you everyone who's watching for watching. Yeah, we'll be doing more of these kind of talks on LinkedIn. We'll be doing more carbon emission type of, climate justice reporting. So yeah, it was really good talking with you both today. And thank you everyone for watching. We'll talk to you soon. Follow Mozilla on TikTok and Instagram and all the places that we are. See ya.